everybody. I tend to pace, so that's deliberate. Okay, so don't be alarmed. Just so I'll be able to go about and steer this the right way in terms of what I'm going to say. Anybody here has a mobile app in their company that they're using, that they're developing? How many of you? Okay, so we got about 15 people. How many of you were actually involved in the processing of developing that app? 1, 2, 3, 4. How hard was it to get it to work right? It's a pain, isn't it? Now, the thing is, people believe, and this is something all of you need to convey to all of your customers, specifically if you're what's called a VAR or an integrator or a software developer, you need to convey one thing. It's not simple. It doesn't matter what SDK you're going to use. There are a multitude of them, all of them, regardless of what you'll use, all of them you'll have to take the same path. And we're going to talk about that path. So just a little bit about myself. I'm the CEO of Greenfield Tech in Israel. I've been involved in the voice over IP industry for about, I'd say, 16 years now. For the past, if any of you ever followed my presentations in the past, you know that I've been strong into security, fraud analysis, and so on. And over the past 2.5 years, I've focused most of my efforts over to voice over IP inside the mobile industry, specifically OTT applications over the top. And we, inside Greenfield Tech, we've accumulated, I'd say, over 15 years worth of experience in developing such applications. So we're going to talk about that. So thanks to the, let's say, the triad that we see up there, which are Viber, WhatsApp, and Skype, almost every application vendor out there, specifically if they're in the social market, want to have voice over IP in some form. Some of them go to the WebRTC track, like Slack, and we see that. It has its own merits and it has its own caveats. But the others go the more traditional way, specifically if they want to enable something a bit more standardized. Now, yeah, so voice, everybody wants it. Why is it so difficult? Why is it so complicated to have something like this? So this is an example of one of our reference applications. And you can think about, well, it's just a dialer. What's so special about it? So let's talk about the special things. Let's talk about the problems that you will carry. Now, just to get a rough understanding of the people in front of me, any of you do have, let's say, dished out a mobile application with voice over IP? Anybody? One. From what company? No fair. Okay. So let's say, sorry? It's still hard. That is true. And where does it become hard? Because if you're going to dish out an application, this is what you're going to be dealing with. And this is just for starters. This is, we're talking about making inbound calls, outbound calls, connecting to the various content providers inside your phone, making sure all the intents and all the actions are done correctly. And of course, you want the general things that an SDK will do. Three-way calling, media transcoding, yada, yada, yada. It goes on and on and on. It never ends. And we've surely forgotten something because up till now, we've only talked about what we call user experience. So we've more or less have a bullet point saying, okay, I want the following feature. 1, 2, 3, 4. Great. Anybody know what's behind those features? Can be really problematic. So we've forgotten a few things. So let's talk about the first thing that everybody forgets. Provisioning. So provisioning inside this environment is crucial. Specifically, if you're a cloud. If you're a cloud provider and you're going to provide, let's say, hosted services to other companies, so you need to be a multi-tenant environment. So I'm going to have somebody coming in right now from OpenShips or Camellia. No problem, we got domains. No, domains are not your immediate answer, and you'll see why immediately. So most provisioning methodologies, and these are the bad ones, will normally take the methodology of taking a phone number and a domain. You know what's wrong with that? Can anybody tell me what's wrong with using just a phone number and domain as your provisioning point for any type of system? Come on, there are about 60 people here. You're no fair. That's what you do for a living, okay? And you work with me, so that's not fair. So the main thing is, this can be enumerated. It's actually so simple to be enumerated that if your platform is ill-designed, I will find out all your numbers in less than 60 seconds, and I'll be able to enumerate all of them and provision a complete attack. Now you want to do something better. You're saying, well, if that's bad, what's good? So let's create a moving target. So this is a moving target. Why is this a moving target? Because no two usernames inside your environment will look the same, ever. And the reason is you've got, as you can see, we have a phone number, you've got a domain designation, and something which is completely random. It will always be random. That hash, you can calculate it according to whatever you want. It could be a timestamp, it could be a calculation on the MAC address of the server, or the IP address of the client, or the IP address of the web client that initiated that, whatever you want. But it creates a moving target. For somebody on the outside to be able to enumerate this, it's a pain. They'll never get to do it. So provisioning is, let's say, so it's step number one. So we now know how to create something that will work for millions of users. How many users do we want on our cloud systems? Millions, tens of millions? Anybody here manage a system that runs over 5 million users? Nobody. Too bad. Damn. So quality. Quality is king. Regardless of what your application you do, regardless of what you will do for provisioning, or how swanky your application will be, or what kind of user experience you're going to take, if your quality doesn't meet up to the standard, people won't use it. How annoying is it to do a WhatsApp call, and in the middle of the call, it's got... Everyone experienced that? Why do people like Skype? Because Skype had gone to extreme measures, okay, to be able to traverse calls correctly and with a high quality at any given time. That takes a lot of effort. So quality is dependent on multiple things. And most people believe that quality is something that is dependent on the application itself, or the network, or the server. Well, truth be told, that is only one part of the story. Because when you're dealing with a mobile device, you have multiple other factors that we're going to talk about that make your life excruciatingly horrible when it comes to developing a mobile app. A couple of years ago, I met somebody that told me, I have no idea why would anybody want to develop a mobile app for VoIP. It's so complicated and so hard that small companies can't do it. And I said, well, small companies can do it if they're minded. So let's talk about the various issues that you're going to encounter in terms of quality assurances. So for example, network quality and convergence. What does that mean? Network quality and convergence. So we want to be able to traverse from a Wi-Fi network to a 3G, an LTE, a 3.5G network, and back while we're on the same call without disconnecting it. Can you imagine? I'm on a call, I'm in the yard, I'm going to go home, I'm on the Wi-Fi, it's gone. How annoying is that? It's like the ever-dreaded, house that has no proper, let's say somebody built your house properly and has a lot of metal in it. It's like a big fucking Faraday cage, sorry about that. And you go in, no cellular reception at all. So you need something else. So that convergence is really important. People don't realize how difficult it is to be able to change your media path and your signaling path for an existing dialogue, both on the client side, on the server side, and make sure that everything keeps on ticking. That is hard. When it comes to mobile VoIP, all of these candidates are dead. Regard them not as dead, and if you see them, that is most probably some kind of zombie codec running about inside your application and doesn't need to be there. Make sure you got your shotgun and just shoot it out of there, because none of them will work inside a mobile environment. And the primary reason is all of these codecs, all of them, rely on one very important thing, and that is a constant bit rate. That means that they need to be able to have a constant bandwidth, constant throughput, constant bit rate without any hicks. Take G722, take G711. If you're going to have a high jittery environment, it won't take. You can put jitter buffers as much as you want. I don't care. It will still not sound right, simply because they're not adaptable. They're not able to do that thing that goes up and down as required. So technically, the only codec you can use inside a mobile environment is anything from the Opus Silk family. Why? These are variable bitrate codecs. They're able to adapt themselves according to the bandwidth that you've got, according to whatever your network is capable of giving you. It will be able to adapt the sampling rate and the bit rate to go up and down as required. Now, here's the funky bit. It is one thing to support it on the mobile device. You also need to be able to support it at the server side. If the server side is not capable of sustaining that going up and down all the time and being able to change the bit rate as required according to the RTCP data that is provided, we'll talk about RTCP in a bit, then you got nothing. It's bilateral. The next order of business is noise suppression and echo canceling. How many of you played with echo cancelers? Like at the software level? How hard is it? Can anybody just, ooh, Matt is at the back. Matt, stand up. I want your one. This is yours. How hard is it to implement an echo canceller? A good one. Why? These tools of echo canceling and noise suppressors, these are dynamic tools. It's kind of like, I'll try to describe it as basically trying to shoot a golf ball into a moving golf hole inside a room that spins. This is what it is, because it is that adaptive. You have to always constantly basically measure what's going around and be able to cancel it. Now, the nice thing is that most mobile devices have hardware noise suppressors and hardware echo cancelers. But the problem is, some of them are good, some of them are bad, some of them are horrible, and the worst is, you never know which is which. So if you've got, let's say, if we have how many vendors for Android devices we have in the world? 100? And each one has 50 different devices? That means we have 5,000 different scenarios. And they only get more complicated with every new device. And for an application vendor, this will be the place where you will spend most of your cash and most of your time figuring out every new device that comes out, how to activate these accordingly. By the way, if any of you think, oh, I'll just put a headset, that needs different activation for these tools, because headsets are completely different again. And then you get Bluetooth, and you go over again. Just goes crazy. RTCP is your friend. Now, RTCP is, when you build your own service, of course you have the luxury of saying, yes, I'm going to use RTCP from mobile device over to my server. Yay! What happens afterwards? Can anybody tell me about a carrier that provides RTCP data? Like nobody? Like, doesn't exist? Yes, it doesn't exist. Carriers don't like to provide RTCP data, because if they will, I have proof that they're shit. They're not providing the service that I pay for. If they provide me with RTCP data, that means I can prove it. Of course they won't give it to me. But we have to make sure as application vendors that whatever we provide is pitch perfect. So RTCP is mandatory, and RTCP is mandatory also to be able to activate other mechanisms inside the entire layers here. And the other two layers are jitter buffering and FEC. So jitter buffering, we're all familiar with jitter buffering. So Jitter buffering has been around for years. The idea is your network has a little jitter, up to 200, 400 milliseconds worth of jitter. So you put a small jitter buffer in there, you'll get a half second of delay, everybody's more or less happy. FEC stands for forward error correction. Anybody know what that is? So in layman's terms, what forward error correction does is the following. Rtcp will report back into your codec saying, I'm sorry, we now have a lot of packet loss. 25% of the packets are going lost. Okay, they're going nowhere. What FEC will do at that point, the codec will actually start transmitting the same packet 2, 3, 4 times in a row for every packet. That means, now you're going to say, what? That means you need more bandwidth, right? Yes, essentially you're taking more bandwidth, and automatically that means that you will have a longer delay because I'm now retransmitting every packet 2 or 3 more times. But at the end of the day, what reaches the remote side is able to basically rebuild your audio, and what you'll get is proper audio. We've seen let's say we've done experiments where we've taken servers up to 45% packet loss with 200 millisecond jitter, and we were still getting audible sound that was capable of listening and talking and conversing correctly with a mobile app. Without FEC, all of this doesn't work. Forget it. FEC is one of the things that Skype holds multiple patents on. There are various patents on FEC. Some of them are available to the public, some of them are really not. And Skype has invested a lot of cash in that. Now, honestly, I wish the world would have looked like this. So we have a picture of, let's see, what we got in there. We got, well, put aside the Windows Mobile, but we've got an iOS, which is more or less standardized. Apples are awesome in that respect. Whatever they dish out is always the same. And we got HTCs, we got a Samsung, and we got a Sony. I wish the Android world would have looked like that. And the reason is, these vendors take extreme measures and go to extraordinary lengths to make sure that whatever they put out is as standardized as possible. So if I'll take, for example, a Samsung J7 and a Samsung A7 and a Samsung S7, they'll behave more or less identically. The electronics are more or less similar. The plastics are more or less similar. The overall configuration is more or less similar. So the tweaks from one device to another are not that bad. But in reality, our world looks more or less like this when it comes to Android. We have multiple vendors. Are you familiar with the Google certification device certification process? Anybody heard of that one? So basically, if you take any Android device and you turn it to its back, if it doesn't have the Google logo on it, it means that it wasn't certified by Google. What? Okay, so that certification process costs a lot of money, both to pay Google to make sure you get that stamp on one hand, and to comply with whatever Google wants you to comply with. So most of the vendors don't take that measure, and they will put out devices that are not fully compliant. And in order to make their devices work, they change the OS. So they take vanilla, your stock vanilla Android, and they'll start modifying it just a bit. And then you end up with really weird devices that do really weird stuff. And now we get to profiling. Now, profiling is something that you have to do for every new device. How does the echo canceller work? How does the noise suppressor work? What happens when I plug in a jack into the headphones? For example, this is a wonderful example because just today the guys managed to fix it. So this company that works with us sent us a new tablet that they're going to distribute. And said, look, whenever we put the headphone jack in, the SDK crashes. We're like, what? Doesn't make any sense. Why would putting a headphone jack into that little piece It's just, you know, a couple metals, just a little electronics. It's not supposed to do anything. Why will it crash the SDK? And basically the guys looked at it and realized that what happens in this specific device, the operating system was modified. So whenever something is put into that specific jack, which can accept multiple devices, creates 8 different context switches on the processor and resets your entire media stack on the device. And that crashes the SDK. Who thought of that? The variance, the sheer number of these devices make this more or less kind of like the old virus writers, virus detectors story. You have people writing viruses, we have people writing antiviruses, and they're always one after another. It's kind of like a chicken and the egg issue. You always run after them. Operating system constraints. Sorry to say, well, not sorry, actually, it's a good thing, actually. Both Apple and Google are becoming more and more aware that people are using their devices for voice over IP and are making life a bit difficult. For example, if you write an application that would run perfectly on iOS 5 or iOS 7, you move to iOS 9, you figure out things are going to break immensely. If you wrote something for Android 5.1, moving to 5.5, you got new issues. Specifically with now with Apple issued the call kit, what is it, phone kit, or whatever. So that needs to be integrated again into your application. And the main issue is what we refer to as interface deprecation, because they go about and they deprecate and change interfaces on a monthly basis. It is literally crazy. Oh, I did this one previously, in case of the Rogue tablet. Conclusion. So what can we conclude from all of this? First of all is that if you're going to create a mobile application, you have to remember that you're going to tackle all of these subjects. They are hard, they are complex to deal with, and you have to dedicate resources. This is not something that you should shun at. Number 2 is, I know it's going to sound real bad what I'm going to say, but don't assume that any software development outsourcing unit can write a proper voice over IP app. We've seen it over and over again where companies and entrepreneurs go about, they reach out to some software outsourcing unit in India, in Bangladesh, in the Ukraine, it doesn't really matter where. And they are mobile developers. They've never done anything with voice over IP, never. And they'll just come in and they'll do the job. They'll put the SDK in and they'll use PJSIP or LinPhone or whatever, but they'll do it and they'll do it as it's written in the documentation, but it just won't work. It will break. And it will break not because the application will crash. It will break because it won't provide what the application needs to provide. And that becomes a pitfall. It turns into that little thing that takes you from being a company that you're saying, I want to make sure that my product goes out, I want to be able to sustain my business, to a company that now runs after its own tail because it's incapable of actually reaching a product. So you have to make sure that whatever you use or whatever company you're going to take needs to do it properly. And they need to have proper experience. And if somebody comes in and tells you, I wrote an application, the response should be, fine, come back after you've written 5. Because 1 doesn't take it. It's a lot of work in there. Yeah, believe it or not. Questions? This is your time to attack me for discouraging you. No, I'm kidding.
We do have a microphone here, so if you have a question, please speak into the mic so we can get it on the video.
Yeah.
What about web apps and going away from the native app and going to some sort of a web app with VoIP. Have you done any of that?
We've done some of those in the past. The results were more or less similar. There's no much difference because at the end, so what are you activating? So you're activating a browser-based application, okay, inside your phone. That will in turn, let's say you're working on Android, then you're activating Chrome. That will activate your WebRTC plugins inside Chrome, okay? But those WebRTC plugins are, you cannot play around with them. So they're provided as is. You cannot go about and start modifying the echo suppressor, the noise canceller. You won't be able to, whatever it gives you, that's what it is. This is the same problem that Slack has, because Slack uses WebRTC. Okay? So whatever they put out through their application is basically what WebRTC provides. So they use that same stack. So they aren't able to go about and play with it. So from their point of view, you know, voice calls is not their main thing. They see it as an additional tool that provides productivity. It's not their main thing, but we are telecom people. Voice is our main thing. So it's a little different. WebRTC is honestly a wonderful tool. We've done a lot of work with WebRTC, both for voice and video. To get things right over a browser link and get it to be as it should be, it's not that simple. We recently finished a project where we were contracted to create a WebRTC SDK specifically for video. I can tell you that the amount of native code that was written in there is staggering. Simply in order to sustain, for example, H.264 transmission and VP8 and VP9, it's just too much. You can't do it with normal browser stuff. It's too complex.